Hello, and welcome to Conditional Probability. This PowerPoint shows the difference between the probability of A given B and the probability of B given A. And my example will be this 1950s cancers test. Let's get going. Here's your situation. In the 1950s, doctors developed a new cancer test. The test was promising. If you had cancer, the test would find it 80% of the time. If you didn't have cancer, it would say so 90% of the time. Sounds pretty good. So if you took the test and the test said you had cancer, what are your chances of actually having cancer? Well, let's take a look. Okay, let's go through some definitions. The random variable A, this is the event that you have cancer. The random variable B is that you tested positive for cancer. Those are two different random variables. A prime, the complement of A, is the opposite of A. So that would be the event that you don't have cancer. B prime, the complement of B, is that you tested negative for cancer. Now it is given that the probability that you test positive, given that you have cancer, is 80%. This is how we would write that mathematically. Probability of B given A is 0.8. That says the same thing as this up here. Okay? The other thing we were given is this. Excuse me, the probability you test negative given that you don't have cancer, those are those two complements, that would be written mathematically as this. The probability of B prime given A prime is 0.9. That says the same as this. Okay? Those are your definitions. Let's go to the next slide. Given that the probability of B given A is 0.8 and the probability of B prime given A prime is 0.9, what is the probability that you have cancer given you tested positive? Now, how would we write that mathematically? It would look like this. The probability of A given B, A being the event you have cancer, B that you tested positive. I haven't given you this number yet. Can we deduce it from these two numbers up here? Well, the answer is no. To determine this, we need to look at the original contingency table. Let's do that now. Here's the table. The probability of B given A, the probability that you test positive given that you already have cancer, that would put you on this row, a total of 10, 8 tested positive, there's your 80%. The complement would be this row, total of 990 have no cancer, this many tested negative, divide the two numbers, that's where the 90% came from. But we want to know if you tested positive, what are your chances of having cancer? It would be this 8 divided by 103, or 8%. Please note, nothing in this PowerPoint should be taken as medical advice. This is a math lesson and nothing more. Okay? Please keep that in mind.